everybody, and welcome back to another amazing unit provided by Miss Scully, of course. Today we're going to start Unit 8 on exponents and radicals. And I might have said this in class or not, but I can't remember. But exponents and radicals, it's a very, very short unit. There's only like 4 lessons, so I think we're going to be splitting it up into 2 separate mini units rather than one big test. But today we are going to go ahead and start the laws of exponents. Now, most of these you might have seen before, some of them might be quite new, but right now it's just about identifying and knowing what these laws actually mean, okay? So, quick review before we even start on exponents. So, if we get an exponent like 5x to the third, we need to know these parts. It's really important, okay? So, this guy right here, this 5, remember that's our coefficient. This 3 right here, that is our exponent. And this guy right here, the x that has the exponent, that is called the base. So the base and the exponent are connected to each other. If there's no parentheses, that means it's only applying to what it actually touches. Okay? And the whole thing is actually called a power. Okay? So hopefully you identified these on your notes. You should have. Hopefully you did. Okay. And then we have expanded form and exponent form. Now, exponent form is very nice because it's just doing something weird. There we go. It's just writing the base and the exponent. Okay? Whereas expanded form is also being weird. It's actually writing out what it means. So when we say a to the 5th, it actually means a times a times a. A multiplied with each other 5 times. Okay? So exponent form is just a shorthand of writing it out. Alright, so now that we remember what this stuff is about, let's go ahead and look at some laws. So law 1 is called the product of a power. So product, meaning multiply, is when 2 powers, a to the m and a to the n, get multiplied together. They actually have the same base. So this law actually allows us, if they have the same base and they're being multiplied together, that means it's just going to be that base and the exponent is actually going to be added together. So m plus n. Okay? Here is an example. If we have x to the 4th times x to the 5th, again, same base, that actually equals 4 plus 5 equals 9, so x to the 9th. And you can think of it in expanded form. X to the 4th means x times x times x times x, 4 times, right? Times another 5 x's. So that means you have 9 x's total being multiplied together. So that's why you add them together. Okay? So that is our first one, product of powers. Next one is the power of a product. So when you have, you have an entire product, 2 things being multiplied together, that are being brought to an exponent. Okay? So here's an example. We have a times b. This is the product, and that's our base of our exponent as well. I gotta sneeze, I'm sorry. I'm sorry. Anyway, so a times b, that's our base, but it's also a product. So when that happens, that exponent is actually being applied to both parts of the product. So we distribute that exponent. So it's a to the m times b to the m. Okay? And here's an example. We have xy to the 3rd. That means x to the 3rd times y to the 3rd. And you can think of it like, okay, if we multiply this out, xy times xy times xy, then we rearranged it, we actually have 3 x's being multiplied together and 3 y's being multiplied together. So that would mean x to the 3rd times y to the 3rd. Okay? Another one would be 4s. So even when we have a coefficient, same thing. That 2 gets applied to the 4 and to the s. And we can go ahead and take it a step further because we know what 4 squared is 16. So that's our simplified form. Okay? And that's power of a product. Now, when we go through this, the names themselves are not going to be super important. However, applying what these laws are is very important. Okay? So this next one is law 3. It's called the quotient of powers. So that means you have 2 powers being divided by each other. So they're a quotient. And they also have the same base. So when they have the same base, instead of adding them together, we're going to go ahead and subtract them. The exponents, that is. Okay? So here are some examples. We have 2 to the 7th over 2 to the 6th. Now you could go ahead and multiply this out, but that seems like dealing with awfully big numbers. But if you go ahead and do it, 7 minus 6 gives you 1 to the first, which is just 2. Done. Another example, g to the 11th over g to the 4th. Well, 11 minus 4 is 7, and they have the same base, so g to the 7th. That's it. Okay? Alright, the power of a quotient. So that means you have a quotient on the inside now, and you have the m on the outside, the exponent on the outside. Well, same thing like with the power of a product, you're going to apply that exponent to every part inside. So we have a quotient of the base, we're going to go ahead and distribute that exponent to both the top and the bottom. So x to the m over y to the m. Now we can't go ahead and subtract these exponents because they don't have the same base. All they have is the same exponent, which doesn't really help us much. Okay, and here's an example. We have 3 over k to the 4th. Well, that means it's 3 to the 4th over k to the 4th. And we can go ahead and simplify 3 to the 4th, which is 81. Okay? Next we have a power of a power. So power being brought to an exponent. So here we have a power, and then we have a power around that as well. When that happens, we actually just go ahead and multiply the exponents together. Okay? Just go ahead and multiply them. So we have v to the 4th to the 5th. That means we have v to the 20th. And you can expand it out too. If you have v to the 4th times v to the 4th times v to the 4th 5 times, and you expand those v to the 4ths out even more, you're going to have 20 v's all being multiplied together. Okay? And that was power of a power. Next one is a negative exponent. If you have a negative exponent, like on top, meaning in the numerator, that actually means it's a fraction. So you flip it upside down and put a 1 over top of it. So now it becomes a positive exponent on the bottom. Same thing, even if you start with the negative exponent on the bottom, that means it needs to get flipped back. So it becomes a positive exponent on top. Okay? And here's an example. We have y to the third, or to the negative third, really means 1 over y to the third. Okay? So the negative exponent is going to make it a much smaller number. So making it smaller, we use fractions. There's another one. 3 over t to the negative 2. Okay, so this, since it has a 3 here, I would go ahead and bring this t up here to the top with the 3. Okay? So it becomes 3t squared. Alright? Okay, and then we have 0 exponent, where anything that has a 0 as an exponent, that whole power becomes 1. It's always equal to 1. Okay? Doesn't matter what the base is, doesn't matter, well, it does matter what the exponent is, but it does not matter what the base is. It will just become, the whole thing will become 1. So we have 3 to the 0, it's equal to 1. We have 3v to the 0. Well, here only the v is being raised to the 0, so that whole v to the 0 gets made into a 1. Multiplied by 3 gives us 3. If there was a parenthesis around the 3v, and the 0 went on the outside, that whole thing would be brought, that whole entire power now, regardless of the base, even though the base is 3v, the whole thing would be turned into a 1. Okay? So now you're going to go ahead and try on your own. You're going to identify the exponent rule and then simplify it. And you need to write all your answers in positive exponents, so no negative exponents. Okay? Okay. Go ahead and try this on your own. When you come back, I'll have the answers for you. Okay, so this first one, this is actually a quotient of powers because it's one quotient and you got the power being divided by power. When that happens, you have to subtract. So 2 minus 6 gives you negative 4. It's a negative 4. But we can't have a negative exponent, so that means it needs to be flipped to the bottom. So 1 over p to the 4th. That's all you have to do. B, this is actually a product of powers. So when you have product of powers, that just means you add them together. So 6 plus 5 gives you 11, so c to the 11th. C is a power of a power, which means you go ahead and multiply the exponents together. So you get h to the 90th. Okay? Again, another power of a power. So you go ahead and multiply them together. So you get y, where is it? Oh, y to the 18th. Here, we have a product of powers again. So you go ahead and add them together. So again, you get w to the 11th. And here again we have a quotient of powers, so you go ahead and subtract 10 minus 2 gives you 8, so you end up getting a to the 8th. And that's it. So we are going to practice this more in class. If you have any questions, please write them down. We'll be happy to go over with you. Majority of this stuff is just going to be memorizing those laws, like understanding what they mean. Okay? So we'll be practicing a lot more in class though. Alright? I will see you next class. Have a good day, and bye-bye.